Let's dive right into this explainer. Today, we're looking at a truly flawless 16-question data sufficiency practice run, pulled straight from our source material. We're going to break down the exact step-by-step strategies used to achieve a perfect 16 out of 16 on these notoriously tricky GMAT and GRE problems. So if you've ever felt completely bogged down trying to calculate exact numbers when you really don't even need to, you are absolutely in the right place.
To keep this super efficient, we've grouped these problems thematically. We'll start by cracking the underlying logic. Then we'll conquer Venn diagrams, master algebra and numbers, navigate through geometry and motion, and finally, tackle real-world rates and profit. This way, you'll see exactly how the core strategy just effortlessly glides across completely different math concepts.
All right, let's kick things off with that first piece, cracking the overarching logic and tracking those missing variables.
Now here's the most fascinating secret about data sufficiency. It isn't actually about doing the math. Nope. It's a test of pure logic that's just wearing a math disguise. It's really just a hunt for missing variables. As we saw throughout the source material, the absolute best question you can ask yourself isn't what is the answer, but rather what piece of this puzzle do I still not know? By simply figuring out if you have enough information to solve it, without actually doing the agonizing math, you save a ton of time and dodge those nasty logical traps.
Okay. Moving right along, let's see how this applies to conquering Venn diagrams and overlapping sets.
This brilliantly illustrates the master key to literally any Venn diagram question out there. The formula is total equals group 1 plus group 2 minus the both group plus the neither group. As the source material points out, you absolutely have to account for that overlap, the both, and the outliers, the neither. If you're missing just one of those pieces, your whole equation completely falls apart.
Let's look at the 60-car problem from our source. The prompt asks how many cars had neither power windows nor stereos. Statement 1 tells us 20 had stereos but no power windows. Okay, statement 2 tells us 30 had both. Well, even if we combine those statements and plug them into our formula, we are still completely lacking that neither variable. Because we have multiple unknown groups missing, the statements together just aren't sufficient. Boom, the correct answer is E.
Next up, we're shifting gears into algebra and number properties, where we really have to test the limits.
Sometimes, you don't even need a formula. You literally just have to test numbers to prove sufficiency. The question here asks, if n is an integer, is n plus 1 odd? The statements tell us n plus 2 is even. Well, let's just test it out, right? Say n is 2. 2 plus 2 is 4, which is even. Perfect. Then 2 plus 1 is 3, an odd result. Okay, what if n is 4? Well, 4 plus 1 is 5, which is also odd, you see? No matter what even path we take, it strictly leads to an odd result. The pattern totally holds up, meaning we absolutely have sufficient data.
But hey, other times you really do have to get your hands dirty and expand out the equation. The source material walks us through this beast of an exponent problem. Is 9 to the power of s plus 9 to the power of negative s equal to b? Statement 1 gives us a completely different looking equation. But if we casually walk step by step through the algebraic expansion, look what happens. By squaring the terms, that messy middle term magically cancels out to just the number 2. Subtract 2 from both sides, and suddenly statement 1 perfectly mirrors our original question. It is definitively sufficient entirely on its own.
Let's keep this momentum going and jump into geometry and linear motion.
This is where the test makers absolutely love to hit you with misdirection. Take this half-mile bridge problem. We need to find the time it takes car S to travel across the bridge. Statement 2 gives us a constant speed of 30. But right there, that's the trap. That speed belongs to car Y. Because we're looking for the variable representing car S, statement 2 all by itself is totally useless. We absolutely have to combine both statements to relate Y's speed back to S's time. Tricky, right?
Conversely, sometimes they actually hand you more than enough info on a silver platter. In this 10-centimeter hypotenuse problem, we need to find the perimeter of a right triangle. Statement 1 gives us an area of 25, which lets us set up an equation, a times b equals 50, and combine it with the Pythagorean theorem. Bam, we find the sides. Then statement 2 comes along and says it's an isosceles right triangle, a 45-45-90 triangle. That means the two legs are strictly equal, letting us find the perimeter a totally different way. Both statements give us independent, fully sufficient pathways to the exact same answer. Either one works perfectly alone.
Finally, let's tackle Section 5, tracking real-world variables like rates, work, and profit. Word problems are wild, because knowing the total isn't always enough.
Here's a really fascinating one from the source. Did the profit exceed $4 million on a sale of 380 units? Knowing that profits increase as you sell more, but not in a strictly proportional way.
The crucial thing here is evaluating if these financial milestones guarantee our outcome. Statement 1 says profit exceeded $2 million on 200 units, but since the increase isn't proportional, the exact proportion variable is missing. 380 units might only hit $3 million, so insufficient. But check out Statement 2. It acts as a brilliant logical ceiling. It says profit exceeded $5 million on just 350 units. Even with varying proportions, if 350 units cleared $5 million, then selling 30 more units mathematically must clear that $4 million threshold. Statement 2 alone gets the job done.
And they really love to hide distributions in these word problems. The source highlighted this perfectly with a net income problem, where they gave a gross income increase but hid the deduction percentages, and a 54-hour workweek problem, where they gave total hours but hid how many were regular versus Sunday overtime. The takeaway is always the same. Whenever specific distribution details are missing from the equation, you are stuck. The statements are insufficient. You simply can't solve for a total wage if you don't know how many hours go to which pay rate.
Which brings us to the final result. By rigorously hunting down these missing variables across every single math discipline, whether it was searching for that neither group, tracking car speeds, or sniffing out hidden overtime distributions, the source material achieved a flawless 16 out of 16 score. It proves, without a doubt, that this variable hunting framework is an absolute game changer for the GMAT and GRE.
So, the next time you sit down with a data sufficiency problem, I want you to pause for a second, take a breath. Ask yourself, are you desperately trying to do the math to solve for X, or are you cleverly hunting for the missing piece of the puzzle? Are you ready to stop solving and start hunting? Keep that framework in mind, and you'll find these problems become a whole lot less intimidating. Thanks so much for joining me on this explainer today, and keep learning.